Today we're going to be talking about day 4, which is complex zeros and the fundamental theorem of algebra. So we're going to take a look at the fundamental theorem of algebra first. So it says a polynomial with degree n will have n complex roots. So if the degree is 5, then it's going to have 5 solutions. These solutions, or these roots, they can be real, or they might be imaginary, so they might be non-real. The real solutions will show up on the graph, the non-real solutions will not show up on the graph. And then sometimes the roots may be repeated, so remember when we talked about multiplicity, that could also be happening. So something that we're going to throw in today, if a complex number, so a complex number, we're talking about an imaginary number and a real number together, so in the form a plus bi. If it is a root, then its conjugate, so it's the same thing with opposite signs, will also be a root. Here's what I mean. If I tell you that 2 plus 3i is a solution, then x equals 2 minus 3i will always also have to be a solution. Okay, think about the quadratic formula, how we always have plus or minus, they always come in pairs, that's one. So if I tell you we have negative 4i, then we will also have positive 4i. They always come in pairs. The same thing with square roots. So if we have 2 plus the square root of 3, we will also have 2 minus the square root of 3. Or if we have the square root of 7, we'll also have x equals negative square root of 7. So imaginary numbers and square roots come in pairs, so they come with their conjugate. It's just the opposite sign, but they always come together. So what we want to do first is we want to write We want to write a 4th degree polynomial that has roots x equals 3 with a multiplicity of 2 and x equals 3 minus I. So when we finish, because it says it's a 4th degree, we should have x to the 4th. So here it says we have x equals 3 with a multiplicity of 2. So if we want to work backwards, x equals 3 would be the factor x minus 3. Okay, you change the sign to make your factor. And the multiplicity of 2, remember that's the exponent. So there's that part. If they're telling us we have a solution that is x equals 3 minus I, that means we also have one that is x equals 3 plus I. So a lot of times they will only tell you one and you have to know that you have the other. So to write those as factors instead of solutions, we're going to change all the signs. So we're going to have x, change this to a negative 3, change this to a positive I. So when you're making them into factors, you're just changing the signs. And then over here, we have x, we'll have minus 3, and we'll have minus I. Alright, always multiply out your imaginary parts first. So I'm going to take these two and multiply them out. If you like to use a box and you want to do a 3 by 3 box, you can, but I'm just going to multiply. So x times x will give us x squared. X times negative 3 will give us negative 3x. X times negative I will give us negative ix. And negative 3 times x will give us negative 3x. Negative 3 times negative 3 will give us positive 9. Negative 3 times negative I will give us positive 3i. Then I times x will give us ix. I times negative 3 will give us negative 3i. And I times negative I will give us negative I squared. So let's look and see what we could cancel first. So if you see I have a negative ix and a positive ix, so I can cancel those out. And I have a positive 3i and a negative 3i. Alright, if you remember from previous classes, I squared is equal to negative 1. Okay, I squared is equal to negative 1. So because I have negative I squared here, this is negative times negative 1, so this is going to be a positive 1 here. So to write this out, we have x squared, we have negative 3x and negative 3x that I can make negative 6x. And then I have this 9 and this 1 that will give us a 10. So when we multiplied out those two imaginary factors there, we ended up getting all the imaginary numbers canceled out, which they should, and we just ended up with this quadratic here. Alright, so I do need to multiply out this part. So whenever you're multiplying out something that's squared, you can use a shortcut. So it's going to be x squared. If you double this number, so negative 3 times 2 is negative 6x. And then if you square that number, negative 3 squared gives you positive 9. Or you can just literally multiply it out. X minus 3 times x minus 3. So now for the last part, we just have to multiply this whole thing out. Really the biggest thing here is you just have to be careful when you're doing this. So x times x, or x squared times x squared gives us x to the 4th. X squared times negative 6 is negative 6x to the 3rd. X squared times 10 is 10x squared. Negative 6x times x squared is negative 6x to the 3rd. Negative 6x times negative 6 is positive 36x squared. Negative 6x times 10, negative 60x. 9 times x squared is 9x squared. 9 times negative 6x is negative 54x. And 9 times 10 is 9. So we can just combine our like terms. So x to the 4th. Then I have minus 6x cubed minus 6x cubed. So we're going to have minus 12x cubed. Then I have 10x squared, 36x squared, and 9x squared. So it's going to give me 55x squared. And I have negative 60x and negative 54x. So that's going to be minus 114x. And then I just have that 9. So this is our 4th degree polynomial that we were supposed to have. We started out with the roots of x equals 3 with the multiplicity of 2. And then they gave us one of the imaginary. We had to know that the conjugate was also going to be a root. And we changed those into factors.